Hi, my name is Will Jarvis, and this is my physics experiment. So my problem statement was, what is the effective trajectory angle on the horizontal distance traveled by a ping pong ball? And right here you can see our launcher. I got the basic plans for this from Khan Academy, and there were a few adjustments were made, so it's not the exact same. And I'll go ahead and get into how I made this. So I have two 1 foot square wooden planks right here, which are connected with these hinges right here, screwed in. And then I have this right here. This is a really important piece. We have like a 6-inch square wooden plank with various holes drilled in with a drill bit. And these are essentially just the angles that can be used to launch the ball. And this is, of course, going to be our independent variable. So we have this here. And we actually are using the drill bit right here to hold this, because it's the exact same size as the holes. And right here we have our spring held there with the nut and bolt, and then our aluminum bar right here in the middle is being held here with like two washers as well, one below and one above. And this simply allows for it to turn a lot more smoothly, even though it's screwed in pretty tight. Another little piece right here is we have the stopper right here to stop this aluminum bar as it's launched up. And this allows for more consistency, of course, with the launches. And it's not actually taped here to keep it in place. It's actually taped here to stop it from rotating. The screw right here was screwed in, and it went through the bottom of this to allow this to stay in place, although it kept rotating. So we went ahead and taped it so that it wouldn't rotate. And then right here we have the string and hook mechanism, which is used to launch it consistently and reliably. So we have this little hook right here, and then there are two strings attached to it. There's one on the front tip, which is the one that we're just going to go ahead and pull, that allows this ping pong ball to be launched, because all the tension's released from here. And then, as I was mentioning before, we have this string right here, which is being attached to here, that is on the tied onto the other end of the hook. And this, of course, is what is holding this aluminum bar back. So whenever we pull this, then this is going to go ahead and launch. And of course, our hypothesis is if the ball is launched at 45 degrees, then it will reach its furthest distance. And this is simply the theoretical maximum distance, but due to factors such as air resistance and gravitational pull, etc., as well as like just many other factors, it will most likely not be exactly 45 degrees. Probably a little bit higher or lower, but I'm sure it'll be close to there. And then that's pretty much it. So I'll go ahead and give a demonstration. Whenever I'm actually doing my trials, I go ahead and wet the ping pong ball so that I know where it first bounced on the ground, because I can see it from the mark of the water. But for the purpose of this demonstration, I'm going to go ahead and just skip that little procedural part and go ahead and launch it. And it's not windy at all, so that'll also increase the consistency with which it's launched. And so I'm going to go ahead and do it right now. So you can see we would have had the water to like mark exactly where it hit the first time, and then we can go ahead and measure that distance using a tape measure, and we can collect our data that way. So after doing many pre-trials as well, I found that it's very reliable, and it has like a very consistent launching mechanism thanks to this little hook and string, and the path from like with which the ball travels is very consistent as well, no matter the angle. Although it like of course travels further at some angles, the actual like direction it's going is very consistent, which is very helpful in determining the validity of my results. So that is my video for my experiment.